I had a section of my talk that I was going to really talk about the history and from the beginning when I was getting involved with it and the development of why the Eaganmatrix came out and the different processes we used and where the state of it is. But I don't think, in terms of time and also the fact that I really want to get into this ratio synths first, I'm just going to skip through that. I do have all those slides if you really want. I think we're going to, once we archive this thing off, we're going to take these PowerPoints and make them into PDFs. So
Can you do it another time? Can you do it another time?
I'll do it another. I actually
want to hear all of that.
Okay. Well, you know what? I'll get into it. Maybe if we have a free time, I can sort of put them up, and whoever's interested, But I know that when we get into this thing, there's going to be. I want to leave questions for, this new stuff that we have here. So as Lippold had talked about was this idea of. I will talk about the history of the specialty synths. So we had these particular synthesizer designs. They were prototyped outside of the Continuum. And then Lippold took them and using algorithms that he was familiar with, started to design these things inside the Shark that was in the Continuum. And it was a tough process to go through because you would put them in one system and you're trying to emulate it in another system. It's almost like trying to play two different instruments. So we quickly, and by quickly I mean like over years, decided that we would really like to have this environment of the Eaganmatrix. And the Eaganmatrix came about from my experience with sound design and particular synthesizers that I was familiar with. So the design that I had come up with, there's a lot of things that have to happen in order to map all the expressive possibilities we have in the playing surface and to be able to make them so that you can edit them and place them. And it requires not really complicated math, but it also, it's just in a structure that a lot of people weren't familiar with, and our attitude was always about that. Like when people would come to say, "Oh, the Eaganmatrix is so hard to program," we were just wishing people would play these, because it's about, people should be just. You would never say, "I'm going to design a violin." You might change the types of, particular strings and you might switch out a bridge and experiment that way, but you're not going to really fundamentally try to change the instrument. You're going to play it and take it for what it is. And we were hoping that the Continuum would do that. Now, when we went into a market which is full of musicians that the emphasis went from a lot of performers to sound design as part of the performance. And there's absolutely nothing wrong with that. And it's actually a really valuable skill to do. But there's certain paradigms that happen within that sound design. Some very, very basic things that became ubiquitous. So even if you have an FM synth or a sampler or a subtractive synth, they sort of follow the same sort of structure, same thing. So then cut to our relationship starting up with Expressive E. And so now Expressive E takes our sound engine, puts it into their beautiful keyboard, and it opens it up to a world of people that are familiar playing piano and playing polyphonically, and it's sold to people that have a lot of synthesizers, and they are used to tweaking and modifying their own sounds. And so it's you can take a preset that's in the Continuum and you can say, well, I like this, but I would just like to make it brighter. And it's non-trivial, to do that because there's just all these cross-related things have been specifically set up. So we decided that we would put this, the ability to have external MIDI data streams really control parameters, and that required a growth of, well, as Lippold had talked about, like within the MIDI data structure and setting up these packets and these particular things. But also it required having a lot of hooks into the system. So, even on very, very simple synthesizers, like beautiful synthesizers like a Moog, when you look at it, there's actually a lot of input that goes in from all these different parameters, and they're all cross-related. So we have a growth in our macros and a growth in our formula, and the ability for those macros to go and to interrelate with the formula in, like, I think it was at 7 different points that we have for every single formula. So we doubled the number of formulas. We set up these macros. We have, and we expanded that out. And it was a very interesting experience for me, because what you're doing is you have a combination of resources that you're trying to manage, and you have to figure out the balance between, we need these certain number of things and we need these certain number of things, and how many do we need in order to make something that's what I would call full-featured. That you look at this and you would say, well, this is like a finished synth. And then, and what I came up with as kind of a proof of concept is this ratio synth. So in a sense, it's kind of like hardwired in the sense that you have this signal flow, and I prototyped this whole thing in Max. But really what this is Max as a unidirectional control using MIDI to control the Eaganmatrix sound engine. And so the basic concept is you have a structure. Our presets are saved as .mid file. So that particular .mid file is loaded into the continuum, and it's sitting there and it's waiting for all these commands to go through. And it doesn't, and for you to interact with the synthesizer, you need an external GUI of some sort in order to change all these macro parameters. And it's a unidirectional thing. So the continuum doesn't have to know anything about the GUI. All it needs to do is get this MIDI data coming back into it. So that was I use Max. I'm familiar with it. I'm a sound designer. I know enough about programming just to get myself in trouble in a certain level. But I don't know the very, very hard things. So we came up with this. What I came up with, I thought, well, a thing that is very, very wide-ranging sound-wise, and I like it, and it's very easy to understand, is a simple FM synth. So this has your typical subtractive flow where things happen from the left-hand side to the right-hand side. And it's something that everyone is super familiar with, and it just becomes, there's no reason not to do it this way if you're trying to make something that everyone is sort of familiar with. So it's got this FM structure, and if you've ever looked at like any sort of FM things, they have like, 6 operators, 4 operators. You can change how many carriers, how many modulators. This one is super complex in the sense that it's got 1 modulation oscillator and 1 carrier oscillator. So, but within that world, like there's a tremendous number of things that you can do with it. And we were using essentially the same components that existed in the Eaganmatrix now. So this didn't really require any sort of new modules to go but what it required a new way of interacting with those modules. So I built this thing in Max, and it communicates directly with this unidirectional MIDI. So in this prototype I have here, I went ahead here. Yeah. Okay, so the very first part here, if you just look at it from the left hand to the right hand side, I have a preset bank, so you can, in this prototype, well, it's kind of it's finished really, but on a certain level. But if I was to do this and have more time, I would just continue to tweak it and add more things. Because I would say I've used maybe roughly, of the structure that we've set up, I've used maybe 60% of all the resources. So if you really want to go further into it, you can do more. We have, in this interface, I also put the controls for the sustain and sostenuto pedals and the rounding controls. So those were already available through external MIDI. So here we have the oscillator section of this synthesizer. And it's very straightforward modulation oscillator, carrier oscillator. The main thing is that on the left-hand side, you see the modulation oscillator. It's got a depth setting, and that's the amount of modulation that goes from the modulator to the carrier. Below that, you see a frequency, so that's the frequency of that carrier oscillator, the modulation oscillator, and the frequency has a single control. And our controls are all 14-bit resolution. So it means that you can do some very, very precise things. So the jump from 7-bit to 14-bit control is tremendous. Like I said, that's a way, like you go from 127 to 65,000 or whatever. But we did a thing where the fundamental macros are bipolar. So, and that's actually really important when I get over to the carrier. So we have a frequency control, and you can specify it, and it's up to the user interface, like how fine you want to go. An interesting thing with a circular controller in Max is you can dial onto it and just get, if you think about that, there's no way I'm going to get 32,000 control points just by moving my mouse around there. But if you click on that interface and then you drag out, so it's like you've clicked on it and now your circle's bigger, and you move it out here, it's actually controlling that control. And you can do things like fine-tune that frequency control so that you're saying, oh, how many beats do I want? So that's fundamental within the design. So for all these macros, and it's also any design that creates a specialty synth has to be 14-bit, and that's because we've used, we have a particular way of addressing 14-bit controls with an LSB-MSB pair, and the new macros are divided into two groups, and they use a different CC number, and that's where it knows, it just repeats, and so it's 86 and 97 are the CCs for the LSBs. So if you specify a 97, it knows it's into the upper bank. So that makes the 14-bit imperative if you want to do this. Now, we kept this completely separate from the original 6 macros that we have. So the original 6 macros are all just at their same values and their same 7-bit resolution. Optional 14-bit, but here you have to do a 14-bit control. So in this particular modulation oscillator, I can control the depth scaling by an X scaler on the top. I can modulate it by moving that middle circle in that mod depth, and then I can influence the amount of Y and Z control by moving sliders to the left and right of the Y. So I can have a negative influence on the depth or a positive influence on the depth. And that's why this was one thing that we decided, I realized that as I was designing this, it's really nice to go into negative control. So that's why.
It makes it so much more intuitive for the sound designers.
Yeah.
I need to influence this aspect, and it just surfaces it easy.
you may press down on your finger, I want to change the filter cutoff. I want it actually to go down when I press down, not to go up. And in this design, I've set it up so that I have a frequency, but I can control the depth, modulation on that frequency by shape generator 1, and I can choose how much it influences the frequency and what waveform I'm using from shape generator 1. So that's something that you couldn't do before. Like now you can go and change the structure and actually address shape generator 1 and say, I'm going to change the waveform of that thing. And also the phase, you see a phase control on shape generator 1. And then in the carrier oscillator, I have similar things. So I have a tone control, and that tone is the spectrum. So if you're familiar with the DSF or the integrated oscillator, they have a spectrum control, so you can set up that tone. And again, then you can modulate the tone. And you can modulate it by the Y or the Z. And in addition, you can have an influence from the shape generator again with a completely different waveform if you want. And the depth of control from that shape generator is now controlled by, in this case, W, which is a constant. But it could be by the X position or by the Y position or the Z position. So instead of going into what we have with the traditional formula structure, you can design an interface so that it becomes to something very familiar in terms of how someone would control. It's all carried within this complete subtractive structure. Then those modulation and carrier oscillator go into an amplitude control where you have a level control, and again, it can be the level can be controlled by most typically by Z, so that it gets louder as you play harder. But you can also do Y control, or you can just have it gated so that it turns on and off. And there's a balance between all those sort of things. Again, overall level at the top is a persistence, and so whatever is inside the Eaganmatrix is controlling those output levels. You can control that persistence value just by setting it on the slider. Now I have this is the shape generator section, and I'm only using 2 shape generators. One of them I use to modulate parameters within a voice, which is shape generator 1, and the other one is shape generator 5, which I'm using to modulate parameters in the master section. And when you get into the master section, it doesn't make a lot of sense to have the influence of your finger because you have many fingers playing, all being summed into one master section. So as this synth designer, it just decided, well, there's no reason to have any sort of finger control. So it's actually fairly basic. It just has a rate control. Another thing in the shape generator 1, there's the ability to have the setup, turn on and off the looping of that shape generator. So it can be single or continuous. And then we finally move into this area, which is the body. So all those voices come in, and they get summed into the master section. So I've set up here controls for the convolution engine that we have, that we're calling the body. And that top circle, it will animate and show you the depth of how much convolution you're putting in there. Below where it says cloth, that means I can click on that and I can choose any of the convolutions that we have available in our current engine. And this size control, I designed this one that if you switch convolutions, it's going to take all 4 convolutions and switch them. And it will switch them, but it always has the same relationship of pitch. So in that sense, where the size is there, it's actually the pitch of that convolution. But it doesn't necessarily have to be like that. I found this just a very useful way to give me a wide variety of timbre possibilities with a without, there's, you know, it's like an Eaganmatrix, there's so many possibilities. So you have to, one of the things about being a synth designer is using, you know, reducing down the number of variables to what is musically useful. And here's where you see the influence of that shape generator 5. So the central circle means the depth of the modulation. It's going to modulate the size back and forth. And you can choose the waveform of shape generator 5. The recirculator is completely open here in the sense that you can choose how much of a mix you want with the recirculator, what type of recirculator, whether it's reverb or low pass filter or a swept echo, the amount of time. And then I put in an influence of shape generator 5 influencing the time parameter, which is interesting because you can get some kind of glitchy or coursing effects depending how you do it. If you want something glitchy, then you don't need to slew your influence of the shape generator 5. But if you do want to create some sort of chorusing effect, and you don't want the little clicky sounds, you maybe want to slew it a bit. So that's also available here in this design. And below it, depending on which recirculator you use, the appropriate parameters will come up. You know, in this particular case, the delay has a low-pass filter, and it has an offset and a feedback. And then finally, in this last section, that shows you the tilt EQ that we have, the final output, where you can adjust the way it tilts and the frequency and then the mix between it. And below that is our compressor controls. And recently, although I haven't even tested it yet, Lipple put into the master section a tan-H function, which is kind of an appropriate place to do it because it creates these interesting compression and saturation type of sounds. Very pleasing. And in fact, I ran the oscillators through a tan-H always. And what it tends to do is, in this one, is make it, FM can be kind of clinical and like edgy. And like the tan-H just like, wow, this feels warm, yeah. And yeah, so anyway, that's all the, those ratio system components. So I just go through here, just go out of it, and now I'm going to go to the actual synth. Show you this. All right. So here's just some presets that I've been just working on, experimenting with this thing. I'll just play a few of these so you can sort of hear some of the different things that can come out of this. Go back to my original. Okay, here's another. Seasick PPG. So let's play around with this, and I'm going to take off the effect. And you can hear the influence of the body and the different bodies. I love what the 10H is doing to this. I'm controlling the same sound engine from the Osmos and the Continuum surface just by sending MPE from the Osmos into the Continuum. So those are just some of the presets that I came up with. Like in the design, it was only just maybe in the last day that I was working on this, I came up with the bulk of those, because most of the time was spent, implementing bug fixes and things like, or new features. So here is the resources that I'm using in the Hawken editor in the Eaganmatrix engine right now, showing in the editor. So if you look at DSP usage, it's very, very low. And over here is the use of the number of formulas. So in this design, which is simpler than the Genie synth that I've also done, and should be showing that tomorrow. This design doesn't use nearly as many formulas as are available, and you also see that it's not using very many of the things that of the existing components that we have in the Eaganmatrix, but formulas that map into these. For instance, this one is mapped with 3 different macros, actually 4 different macros here. And then it's also adding in another macro 7, and it's also adding in formula U, which then is being modulated by a shape generator, which is its level is controlled by another macro. And that's multiplied by formula V, which then has these, how many we got here? 4 different macros. So you see, you can set up all these complex macros and structure all the formulas together. And, but then the user interface shows that up as just a single few dials, like a little Z control, a little shape generator amount. Yeah, so that's kind of like, that's the ratio synth.
So the question I had is, that GUI, the ratio synth.
Yeah.
Display, it's all talking to this one underlying text.
That's right.
Through the macros.
That's right.
Okay.
Through a MIDI stream.
Right, so these are much more open-ended than a traditional Eaganmatrix preset. In fact, you would never really look at it in the Eaganmatrix as a
you have a
user.
this flat surface area for each of the synth. It's from that
Yeah. Just that patch and different macro control.
The surface area of the GUI.
Yeah.
Right.
And you decide within that structure, like here's an FM structure. So here's the world that I'm going to explore within those FM, which is, pretty wide. And you listen to the presets, and there's quite a different range of chambers. Yeah.
And this is just one.
This is just one.
Surface area.
That's right. Yeah.
So, this is just
Yeah. And so,
It's just I don't, because I can say this, he's going to be too humble to say this, but there's actually a lot of skill in this, because while there's all these macros feeding in, it's not really, you have to figure out all the levels and offsets and transfer functions and all this stuff to even make it make sense. And so the skill in making one of these is beyond even what you really want to start making Eaganmatrix presets first, because trying to make an open-ended thing seems like, I don't have to make all the decisions, but it's actually worse than that. You have to sort of.
You don't want that. It'd be overwhelming.
But on the other hand, it's an interactive process. I mean, I saw him rebuild this n times for n to some integer, and
higher than
each
10.
Time, each time little things change. But one of the really basic things he did is that little control where you say how much y, how much z influences this. It's actually very powerful, and it's actually sort of surprising.
or I would do things like, like I set up, let's suppose you had a particular control like this depth control here, and it's kind of like a linear relationship in the it's linear. It's a linear relationship inside the Eaganmatrix sound, but the control is a power function. And one of the beauties, one of the dangers if you're dealing in the 7-bit world is that if you start to scale and offset, you're just reducing your bit size. But if in when you have 14-bit, you have the liberty to do that, and you won't notice those effects. You have to go really, really extreme to notice those effects. And so in Max here, this is designed with certain subcomponents that have a input, and one of them is a power function. I forget which one. Anyway, it doesn't really matter, but I can adjust the power function. So you can make changes to the way that a control interacts. You don't have to necessarily do it within the, I wouldn't have to set that power function inside the Eaganmatrix. I do the, yeah. The only thing that and so the philosophy here on this design, you don't necessarily have to follow this, but this is made so that if you were to load a preset and then it's not dependent on anything being generated from the macro once the preset is saved and it's loaded in there. But if you decide that, oh, well, I'm going to use Max or whatever thing, and I'm going to create my own LFOs, and I'm going to put them into my design, and those change over time, anything that changes over time, you would need to have that interface running. So there's a possibility to do that if you want to do that.
So what he's saying is in this one, you don't, strictly speaking, have to have the GUI running for it to work. But you could certainly design something where the GUI was necessary for it to work. Because here it's really all doing setup stuff. It might be doing scaling and stuff on this end, but after you move a control, it's not automating any more stuff. It's only sending out stuff when you actually move the control, in the way he's got it set.
Does the editor need to be running?
No.
To work?
All it needs is that ratio .mid file inside there.
Yeah.
So
If you want to do that, you were playing the dials and changing the sound
Yeah.
as you're playing. You need UI for that.
yes, yeah. Well,
you
like
need
any
UI
synth, yeah.
Or,
Without the
or,
internet,
or some other control circuits talking to that same thing.
That's right. Yeah, yeah.
I have maybe a foolish question. Is it possible to program like a macro? Essentially, because like right now you can make one knob control like 47 things going in all different directions inside of one preset inside of that Eaganmatrix preset. Like with I'm just thinking, for example, like the Eventide pedals have that cool thing where you can like dial for everything that can be adjusted on it. There's like a range you set, right?
Right.
And you can program that to a pedal, and when I push this pedal, 7 different knobs go in different directions. Is it possible to have like macro knobs that would move 4 or 5 different controls within the GUI?
Absolutely.
But
that's completely,
Formulas.
Josh, that's completely external from the Eaganmatrix. That's just basically manipulating that MIDI data.
Oh, so
Yeah.
you would program that as an instrument. So you
Yeah.
can make all of these things, and then above it you can set like 4 or 5
Yeah.
knobs, and you click on this for this range.
Yeah, or it's like when people have learn functions built into that, so I want to control it. That's all dependent on that external.
Yeah, well, there's a whole design space in deciding whether it's in that underlying patch or you're doing it in GUI.
Yeah.
Because you can do stuff both places, similar things. And so it's
Yeah.
a design choice where you're going to place that and
Yeah.
how you want to control it.
And you're saying exactly the right thing. It's a design space. These are big things. Like, yes, you can do this, but it's not, it's going to take a lot of skill on board. So it's there's nothing trivial about it. What is available is this thing and its widgets. You can copy things. In fact, you'll see it in his other synth, and you'll see it in at least some of it we copy too. You can copy the widgets, you can copy some of the stuff, but this control level stuff you have to figure all that out.
Quick question, for example, like the mod depth of the is that essentially sending a singular MIDI command?
That's right.
So you could easily replicate that in a hardware, like a knob controller.
You could,
Yeah,
yeah.
okay.
Yeah, yeah. Yeah, that's a particular MIDI message.
Yeah.
Yeah, whether it's software or hardware, you know.
We've done it the same way, I'm doing it, but my software.
But, yeah, so it's sort of serving two purposes, like this synth design, it's bringing out the interface in a more familiar way. And it's also taking, in a sense, what Josh was talking about, he says, well, you're mapping all this one parameter, like, you know, like, there's, like, for instance, on that mod oscillator, because of aliasing issues, you actually want to scale off the amount of depth. So while this control appears linear in that sense of the depth, there is a certain amount of scaling that happens in addition to the scaling that happens in this control. So to the end user, this looks like a linear relationship. Okay, but in actual fact, right now, so we can make this so that it favors more change on the lower end of the keyboard of this playing surface. But in actual fact, I did it so that it's bringing down that depth control into the upper frequencies, because you'll just get aliasing if you go too high. Something that sounds musically interesting in the low end, with the depth control really high, is actually will start to alias if you go into it really high.
But that's done later, so if I just emulate that circle with a knob, it would do the same
It
thing.
would do the same thing.
If that translation is in that underlying engine layer, not solely the UI's responsibility.
So that's really the question. Suppose I go out and get a MIDI device where I just map my knobs to the MIDI controls.
Right.
Then I can't have a power curve there or the scaling to the
That's right, yeah, yeah, but if you were controlling this interface, it would happen.
Right.
So that's, again, the responsibility of that. You know, if you were gonna make a bespoke piece of hardware that would do that, you could build those components into it, if you really wanted.
So you could have the knob sending one mini CC to the editor or to the key matrix, but receiving a different mini CC from a hardware.
Yeah,
But there you're doing the same thing, you just have hardware knobs instead of GUI knobs.
There's a plethora of devices.
right.
So you-
Yeah, but there's a plethora of controllers that send out 7-bit data.
Yeah, it's actually
Yeah,
unfortunate because even NVE, right, didn't fix the 14-bit glitch for
Yeah.
for MIDI.
Yeah.
So when if you're in real time sending 14-bit controllers in MIDI, if you do it the standard way, then you're actually getting 6 bits of accuracy instead of 7, and you're better off just sticking with 7-bit controllers. So it's very unfortunate, but NVE dropped that somewhere along the line. People didn't understand it and dropped it. So at this point, we have our own definition of this is how you do 14-bit controllers.
Yeah,
And
that's
if you're
fine.
lucky, you have a controller that can actually encode that. But a lot of, depending how simplistic your controller is, it may just not be able to do it.
Yeah, my module always sends 14 bits.
Oh, yeah, well, then,
Everything is.
and you can get hardware devices that are programmable enough to do it, and some of them do it, some of them don't. If they do standard 14-bit MIDI control, that, if that's what it says, that's, the secret language for it doesn't work right. And we can't use that.
What's interesting about this, for me, is that I came up with sound design here that I just wouldn't have done. I wouldn't have made that many different sounds in a day in the Eaganmatrix. What I would have been doing is I would be whittling my oboe reed down to a particular type of timbre, and that would be the timbre that I would get. But here, this is an exploration in what people are more familiar with, and I ended up with things that, although the structure is, it is relatively simple in terms of the Eaganmatrix, there's a lot of different possibilities, and most importantly, if you have a preset that you've selected and you just want to make it a little brighter, there is one control to do that. And that's what often people do. Or the other thing is, I really like, so I like this particular preset that was done, but I'm finding the modulation too deep. So I would change that value, and also I want more, but then I want more influence from my Z as opposed to the Y control. Or I don't even want the Y control, I want the Y to go positive. And I don't really want that shape generator, but I want, oops.
Well, I'm listening to you and I'm hearing you're speaking in terms of that sound design language. People criticizing Osmos and the Eaganmatrix. That's what they're addressing. You're using
Yeah.
this, you're speaking that language, so you're really solving that problem.
So here's an imaginary scenario. So you have a bunch of Osmos sounds, and inside a bunch of these Osmos presets are a series of things. Like there's a bunch of different specialty synths, and someone calls up ratio, and then the ratio interface comes up, or they call up Genie, and the Genie interface comes up. And these changes happen as fast as current preset changes happen. So, and I can click through presets here, and it just happens really, really quickly.
And unlike the Continuum, the Osmos actually has a real display on it. I didn't say that. It has a less retro display on it, and has knobs and really has the capabilities of having this built into your one device, rather than that is a thing. And
Yeah.
in some ways it works better on the Osmos because they do have that display, and I think this is a real future.
But the other thing here is, this is just one instance of a custom synth that you
Yeah.
built on top of this
Yeah.
framework. So you've created this whole framework where you can create these familiar models of synths.
Yeah.
And that just makes the whole engine accessible.
Right, and so I have other ideas, like I did the Genie one, but I had an imagination for, I'm really interested in things that are using the spectrum, the harmonic manipulator, and I just want to be able to go through and change different things, but I generally want to play them in time. And this would be something that requires special presets for every single time that you did that. Or another one that's very interesting is I want to make a interface that all it's doing is specialized to controlling the CVC. And so now I can take all my shape generators, I can take the graphical 48 value thing and make a sequencer out of that I can then put in, and it's up to me to make an interface for it, but all those things are possible. So it would make CVC design all that more flexible and all the more familiar. So you could say, just in that particular input, I want a combination of shape generator 1, shape generator 2, and I want the balance to happen in a particular way.
So if you're talking to a Euro rack, this gives you a whole nother rack of stuff that you can interact with your physical rack.
Yeah. And then once you save it, it's there. Yeah. And so it's reproducible.
Plug this in.
Yeah.
There's no way to record
Yeah.
those.
Yeah.
So if this was ported to the Osmos, for example, you would essentially you're loading what it sees as a regular preset. And then within that preset, you'd have access to like some version of this GUI.
They have to build a UI.
Yeah.
Right. Because then within you have one preset slot, and within that you could save versions of that preset based on your
Right.
Yeah.
It'd be like a subfolder in preset number 7.
Depending on how they want to do it. But imagine, this pull-down list. So imagine this pull-down list doesn't exist in the ratio synth, but it exists in the continuum of the Osmos. And if I'm searching through my sounds and I say, I'm going to go to glitch bell. If it goes to glitch bell, it knows I'm going to load the ratio synth in the background, and I'm going to set up the parameters for the glitch bell, and I'm going to make my GUI the ratio synth in the GUI. And it just happens as you load a preset. I mean, this kind of idea is not unique to us. I mean, this like the way, what does Reactor use? They use ensembles. Yeah, it's this sort of thing. So, and that's a matter of, you have to understand the Reactor levels. Or Kima was like that too, where Kima has a sound, and then you make a control in it. You decide what's going to be in the control interface and how they're laid out and that sort of thing.
So potentially you could really expand the number of user presets to the end user, you know, in terms of their experience.
Yeah.
How many presets do you have?
Well, I just made a thing, well, potentially each box, yeah. How big's your screen? It's like, yeah.
But these ratios and presets, they all exist in the UI, they're on disk, you don't have those accessible. You can't take the hardware away without the.
Well, this dream world of the future with the Osmos would really have it built in, but it's a huge amount of work, right, to build these interfaces and fit them to that display, and,
Yeah.
there's, we're talking about a lot of work, but yeah,
People
the
underestimate
long-term
what it
goal,
takes to make a UI.
yeah, the long-term
Yeah.
goal is to have it internal. For the Continuum, realistically, I don't think I can make a display like that, so, it could be on your phone, or it could be on your whatever, but it would be,
Some of us build the add-ons.
Yes, exactly.
We could also potentially have hardware controlling it with continual blindly. So you could load up one of these, have the right hardware that communicates with the proper language, switching between your presets or twisting knobs and saving presets.
What's that Eastern European controller you got? That box?
European?
The controller you got?
Oh, I got that. It's that Czechoslovakian, that Czech company. They made a. Yeah, we had one of our users. I can't remember the name of it now, but that requires Lua scripting, which I just didn't want to get into. So
Yeah, but I mean, there are boxes out there that can do all sorts of things. So,
yeah.
Depending on what you got and how big your audience, how big you want your audience to be, you can do all sorts of things.
Yeah, it'll be really interesting to see how this all evolves. Because there's all these little producers making these little, very flexible boxes. It'll be easy for them to target.
It's really nice to have labels, right? If you have really just a bank of, it's so hard to remember what
Yeah,
does
that was
what.
my concern. I mean, coming from what I build, I depend on those text bits of information and parse those so that I can suffer what surface what this macro is.
Mm-hmm.
And all that's still available.
You painted it in text, but you're saying that this is one way. And what I'm talking about is having it two ways, so I can, someone
It can be
switches something,
it can
and I
be.
have to adapt and discover what it is you switch to, and present something useful. So there's some level of two-way that might be needed at some point. I don't know yet.
Yeah, no,
This
it's
is
two
my
ways.
first time really seeing this.
It works one way, but if you want information from the other direction, I mean, the editor uses exactly the same protocol.
Right.
So the editor knows what your presets are called, what your, what everything is, and so it can be.
There's probably a lot, you have the same mechanisms that the macro has, you have the text labels in there, that's all.
Yes, we do have some limited,
parse.
right, because we got 90 of them dang things, so it gets kind of long, we have to figure out. We have still have to figure out.
It's just more space to have that in there, you've got the protocol, that's all still all there.
And the way Lippold set up the protocol is that very specific aspects of the design are available and addressable by MIDI. For instance, if you had a control, like here's one thing that I was going to do where you can have the convolution pre-reverb or post. So you could set up a control to have these same formulas over here, and a switch mutes these and unmutes those. Or you could have a interface where in this particular formula, I want this structure to change. And so you could address that structure. So if that becomes something that's useful and you think it could be into that end system, then that's possible.
I mean, you probably have to learn some of these underlying patches that have just hard codes and this configuration to present a different UI.
But what you quickly realize when you get into this is that within a relatively simple structure in the Eaganmatrix, there's a big world, and there's not a reason to make it complex. It's really something else. So in this structure, you can see I've got this modulator going into this carrier, and then it's going into the TAN-H function. So there's the, this ends up being a level control. This ends up being, yeah, this is the amplitude control. So as I toggle through here, this is the blend control and the amplitude, and here are the particular macros, the influence of Y, the influence of Z, and then there, remember I mentioned the amplitude could just be a gate, and that's the amount of W that you put into that. And as a synth designer, I decided these controls would be better off with that squared function, whereas other times you use a linear. And that's all, you know, those are decisions you make in the background. And the end user just really doesn't have to be concerned. They just deal with these very familiar things. Yeah, Randy?
Have you thought about what to call this specialty instrument design editing?
Well, Lippo's not happy with specialty synth is in terms of a generic term for them.
Well, yeah, or a synth design, but we hope that the synthesizers will have a prettier name, like in this case it's a ratio.
Each
But-
one will have its own name again.
But the person who designs this thing, like what you're seeing on the screen there, is a synth designer. I don't know. We have to come up with something. But
The reactor equivalent.
But this is, at this level, looking at the previous screen you had there, this is just the matrix.
yeah, except you're doing weird decisions because you're making decisions for an open-ended system, and it's a bizarre skill.
Well, yeah, and it's a different approach you have to take, but we haven't changed the UI here.
Oh,
You're not doing anything different. It's still.
no, we really just had to probably look at this. Eaganmatrix is really cool. It does all sorts of stuff. We don't want to give up what it already does, but
Yeah.
you know, it's missing.
This is amazing.
Yeah.
Now we have a pedagogy problem.
Yeah.
How to teach people how to, frame how you think about making things.
And it's also conceited for us to think that we actually know how to make them yet, right? I mean, Ed has a lot of
You were just
history, but these are the first ones.
Yeah.
Yeah, but we can start capturing that information, and have a way of communicating. And, it's a small community that's going to be building this kind of stuff.
Yes, smaller than the people that understand the
Yeah,
Eaganmatrix,
it's another.
which is already a small community.
It's another.
Yeah. Yeah, Randy?
Can you explain the LSB and MSB, like the mapping? Is it the same way that CC87 was used to?
Yeah, so what happens is when you send out a control, the LSB will go out, and it will sit there, and it'll wait for an MSB to come
So
in.
there was two different ones, 97 and 86.
Yeah, 86 and 97, yeah.
So
Yeah,
it's just.
And it's just a way to have two banks of,
Yeah.
Oh, so instead of just using like 86.
Yeah,
It's
just-
just instead of macros in through.
because I wanted to get away from hogging too many MIDI channels, it was getting old. And also, we still have this backwards problem where channel 2 is for relative offsets, because a lot of controllers don't know what's going on, and you just want to be able to twist the knob and bump it up or down. And channel 1, and it was just too much mass to take over multiple MIDI channels, so that was an easy way.
You can spot a whole other channel.
Yeah,
Either
exactly.
way,
And then most of the other communications actually goes through channel 16 polyphonic aftertouch, because polyphonic aftertouch in MPE makes no sense. You don't need that, right? The one place we use it is on the master channel, because that's supposed to be backwards compatible.
And that's why we stayed off of that.
And but we're not using it on master channel, we're using it on the channel 16, and there it doesn't mean anything. So we can use that for sending our data, and that just bought us another 128 MIDI channels, so that was, that way we sort of moved out of everybody's space.
love that stuff.
Yeah.
That part is really.
Well, after talking to you, I figured out,
If somebody
we
understands
gotta do
it
this.
was hard, so the more we move into that, the better.
So Russ just told me a little while ago that we would need to be out of here in 23 minutes. So
I want to get through, so.
Yeah. Sorry, to derail this and go all totally geeky.
No, that's cool, yeah.
Oh, it's great.
So there's your assignment, start designing some specialty synths.
I'm glad you like that.
Having a handful of those would make a lot of people's experience
so less.
They would never deal with the
Absolutely.
Eaganmatrix in that way, they would deal with this.
Yeah.
Yeah, and that's all they would ever
Family
see.
of these.
A family of these, yeah.
And because, a lot of our thinking too is that the Osmos world is much larger than our little corner of the world.
Yeah.
And they have that nice display, and that's sort of the ideal, like that's built into your synthesizer, and then you don't have this, oh, you have your computer, or you have your phone, or whatever
Yeah,
is
this
running.
whole
the
world,
synthesizer.
people will, if it involves a computer, it's an instant no.
Yeah, and there's real reasons for that too.
Yeah.
I mean, that's not, but, and so, we're sort of looking in that direction, and even though we're incredibly in love with our own products of the Continuum and the Continuum Mini, which has a 7-segment display, which is even more retro.
But
It's
this
yeah.
is fantastic for the osmosis, so people have been going around, one of the biggest things.
Because they're primarily tweakers. And they want to tweak, yeah. And I can understand
There's nothing
that.
wrong with that.
Yeah, absolutely, absolutely.
It's like,
Yeah.
right now, it's sort of, you're apologetically saying, well, that's not what it is right now. So,
But this enables people to do things that's not possible by building an Eaganmatrix, because you can manipulate so many factors and say, like, it's.
Quickly and familiar aspects.
Like you're able to make sounds, it's your matrix, and you're able to make sounds with these GUIs that you
Yeah.
can never program in a regular.
Exactly, and there's also this myth, like what's theoretically possible. So like in the Eaganmatrix, it is theoretically possible to have obviously anything you can do in this interface, but will you find it? I've told my students, well, if you really want a general purpose synthesizer that you can make any conceivable sound that you can hear will ever be made by giving somebody a text file and letting them type in numbers, and those are the sample numbers. And any conceivable sound that's ever been made or ever will be made can be made with that synthesizer, no restrictions. And it's also totally worthless. So there's a really important fact here that, I hope tomorrow we'll see with the Genie thing that, how fast you can zone in on stuff. There's no way you could do that typing in.
you just described this, that you crank these presets out in no time.
Yeah.
And
So even though
you've
I'm
never
not-
been done that before, you're just straight in the paper, so.
And
It's
what-
total validation of the work.
And what's interesting for me about it is that actually I find this a really familiar and nice environment to make sounds, even though I'm really familiar with the Eaganmatrix, right? So I mean, I love this thing, so yeah, it's great.
Well, then you can think like a sound designer and not a programmer.
Yeah. And also to go quickly into other worlds, like, that you just can't,
Yeah.
there's just all sorts of possibilities.
So that you make this abstraction, there's like a piece of software that will make these specialty synths. Like, there'd be
Yeah.
a piece of software that will create these specialty synths.
Oh, that would be another level. We don't have that. I mean, basically, he's using Max as his tool, and he built up some widgets, can stick them together, but,
And they all use other tools.
yeah.
I know MIDI and Max, so.
One question, would it be possible to utilize this kind of in a similar fashion, like a touch OSC window? Could it be used on like a Surface Pro or something else? Like, if you have your Continuum, have another device and just, as you would say, moving sliders and so forth. Just
Yeah, you could
Yeah.
build that.
If you had a multi-touch surface and you had Max, you could do that.
I see.
It's just, you touch them and move them.
So this is driven, like the specialty synths will be created more like in the Max environment.
Yeah,
It depends.
one of the amazing things is these specialty synths. They're just talking in some basic, very simple MIDI to the macros that you set up on that underlying patch.
Yeah.
So these are actually really easy to program. It's,
His question could be answered by if you, the designer ratio, made a MIDI interface for all of the controls on your UI, and then you could use Touch OSC to control that.
Yeah.
That's what he's basically.
Okay.
That's what he's asking.
It'll be ready tomorrow.
I love the fact that you created something and you gave yourself a different perspective, like you gave yourself a different perspective.
which was surprising.
That's beautiful. No,
Yeah, it was, I suspected it, but it was really, what surprised me was how enjoyable
It's
that
very
experience was, because I went back into a very familiar world. And also I just designed this synthesizer, so, I knew all these
Yeah.
sort of things.
So you build one of these things, you just build MIDI learner onto that,
Right.
and then,
Assuming your controller.
Can give you the right,
Yeah.
well,
Well, you can do a MIDI learn and you send it a 7-bit message, which then you, inside your interface, you designed it to appropriately give you the 0 value of the LSB. And so then you've got,
doing the translation, you do
Yeah.
MIDI learner, that's something.
so if you had a controller that was done, it was only 7-bit, you could still use it as long as this interface is there. But you would need the interface in the place,
Right.
because you have to have these 14-bit values. So you got work to do, Paul.
So much, yeah, I mean, I've got a lot.
There you go. So tomorrow we'll talk about the G, and Christoph has his wonderful Loris, the analysis, which is an interesting hybrid. It's interesting, very, very. Is there, oh yeah. It's actually more ready than it's ever been.